show the interface between TMS and Mastercam, and then how that interacts, how we build the tools for TMS, which Michael has explained in trainings room. So we've already got the tools built. We're just going to pull them in using the interface, build the whole process in Mastercam, take that operation from Mastercam, import it back into TMS, and then Matt will go through the rest of the process of checking it out from the tool crib simulation to pre-setting it, and then actually sending that data offset information over to the Finnock Rojo for machining the part. So we've already got a demo part preloaded, so all we need to do now is we've got our tools pre-programmed in TMS, which we can see here. Going to manage tool. Open up our library. So for this demo, we're going to be using tools 1, 3, and 4, which we've already pre-programmed using DIN characteristics, defining what the descriptions are, giving it Mastercam article characteristic information so we can use that tool inside of Mastercam. And so now we come in here and using the Zoller import. So this is an interface that we've developed internally. So now we can see, all right, these are the full tool list of all the tools that I have with article characteristic information for just Mastercam. I've got some that are dedicated for Siemens NX, some that are dedicated for Spree, all that. So for this demo, like I said, we're going to use tools 1, 3, and 4, and then use the import function. And now it's going to ask me what article characteristic I want to pull into the cam info also. So we used to actually manufacture aluminum with coolant. Now we're using just plastic or Delrin and no coolant because we don't want dysfunctions. So we go in, accept the feed and speed rates for each tool for machining plastic. And then it'll say that these tools have been imported successfully. So now we come in and we have to assign those tools to the parameters that we've defined. So I come into my tool manager in Mastercam, verify the tool path, and this operation is going to be the same in every CAM software once you pull in the tool information. So now, again, for my outside contour, I'm going to pull in the tool, verify the tool path. I use the same tool for my inside pocketing as well. So, same procedure, pull in tool 3, verify the tool path, and then I drill, come in here, tool, I use tool 4, and verify the tool path. So now I can come in here. And actually, in Mastercam, it's nice because you can actually run simulation mode inside Mastercam. So now I can go in, I can check just a single operation, or I can check each operation individually. For this one, I'm only going to run the drill operation. I see that it checks out. If you guys didn't have a CAM software that used a simulation service, or if you guys are using like Vericut or anything like that, what we would do is we're programming our part in Mastercam, import it from Mastercam back into TMS, and we take that same setup sheet with those same 3D models, and import them from TMS into Vericut with that milling operation, G-code, everything, and run that program in Vericut to do collision detection to make sure that our holders aren't running into the part. So now that I've verified that my toolpath is good in Mastercam, what I can do now is I can come in here and I can use the Zoller export function to export the full graphic with the parts list. So I can say I've got tools 1, 3, and 4 again. And I'll say this is setup sheet 1976, designation, demo part. Throughput time is 35 minutes. So this is how much time did I spend in my CAM software creating this part. Because in our gold level of software, we actually take that throughput time, and if we've got a part that has to go through 10, 12 different operations, it combines all those throughput times and says, okay, your total allotted time for this master part across all 12 of those programs is X amount. And we can see that and track it. That way we can build a part accordingly, just inside 2 minutes. So that the programmer...
So you can go in and modify the program so you can cut all that extra cycle time out that you're pulling out.
Yeah. Yep. Machine is our
That's what we're thinking. You know.
And then
It's
our
your
graphic
point.
groups, I'm just going to put in 10. And now I can simply export this setup sheet into TMS. So now I can come in here and I see, all right, I go into my setup sheets. I can go into my library and see that I've got one part that I created earlier and I've just created this part. So I can see that my designation is my Delrin demo part, what machine it's going to, throughput time, and now I actually have my parts list. And I can also come in here, import NC programs if I have any, import those, track those. If I have to make revisions, I can track all that information in here as well. So we've actually made a cleaned up version of the same demo part, which is right here. This has all the information that we see here. So we've got a little bit more information here. Same part, same tool data. This time we've got NC program, and I can actually come in here and I can see the NC program that is currently released with this. And if I can actually, if it's a text format or just a NC file format, I can actually view it inside of TMS. Because the file is so small, if it's like a rich text format, we can't view it because the file is too big. It has to be, I believe, below 15 kilobytes. But we can still view this NC program in here, which is nice. And I can keep track of revisions and all that. And I can actually, in TMS, we can send the NC program to and from the machine with inside TMS and the machine controller using a file share. So now that the programming part of it's done, we send it over to Matt, and he's going to come over here and actually check out the tools, go through the procedure of measuring them, and then machining the part.
Here that we've added quite a bit more information, but now what we want to do is actually transfer, take these tools out. So we'll go through and check them out. So what we can do is that when we check out these tools, we want to have a level of traceability that we can track these tools throughout our shop. So the default here we kind of set up as our machine. What machine are we going to? Maybe we want to add the individual that we want to track this with. Cost center, department, part number, or even if you have some customer specific behavioral fields that you want to add that level of traceability, you can do that as well. So we'll go through, we'll check them out, and what we can do in this case here is that we can check out tools as a full assembly or as individual components and assembly tools that check the tools after. So what we'll do is that we'll check out tools 3, 1 and 3, and check out the single components of tool number 4. So if we wanted to create a picking list, we could do that, remove a list. What we'll do here is that we'll dispense our drill out of our micro twister, and what we'll do is our collet, and then we will dispense the pulse. And then our software is going to transfer us over to the different tool cabinet. So right here, lit up here, it's telling us that we need to go to the first pocket here for our face mill. And then we need to go to the third pocket for our end mill. And then right here, it's telling us to grab our holder for our drill, collet, whole stud assembly. I'm going to cheat. I've already got it assembled. So, what we can do, close that up. And now what we can do is that I can show you here is that with all that, with assigning the tool to the machine, cost center, person, and whatnot, what we do want to look in circulation, find out where this tool is, and the software does track that for us. So we can accurately find these tools out in our shop. So, what we can do now is that I have the tools pulled. Now we can go over to our Venturian measurement tools. The controller, and then run the main program. Scan them. 1, 2, 3. Tools. Part. So now I want to pull this information into the control. So now what I'll do is hit fire input.
Yeah, we take somebody as a special tool or we get all of our
Use this in the main program. So you can take a look here. So these are the values that I'm going to pull into the machine here. You notice that they are the same. I just like to show them. They are the same offset values, 94, 924, 94, 924, and so on. So what I'll do is I'll go into my offset page, break these guys out just to show you again. And I'll just transfer the data. Very beautiful, easy, no chance of bad fingering. Okay, so now I'll go through and make my main program, run the actual NC program for this part. Lock. Run the program. Now we'll manufacture.